In this video, we're going to do some extension questions on algebraic fractions. We're asked to simplify the following fractions. So let's start with A. We've got 1 minus x over 1 minus 1 over x. I'm going to multiply the numerator and the denominator by x. If I do that, in the numerator, I'm going to have x multiplied by 1 minus x. And then in the denominator, I'm going to have x minus 1. We can simplify this further. I'm going to take a factor of minus 1 out of the bracket in the numerator. I could of course do that in the denominator. I'm just going to do it with the numerator. That will give me minus x, then we'll have x minus 1 over now x minus 1. We now have the common factor of x minus 1, which we can cancel, and that will simply leave us minus x. So as stated, you could have taken it out of the denominator. We would have had minus 1 and then 1 minus x and simply cancelled off. With b, we've got 1 plus 1 over y, and then that's all over now 1 minus 1 over y squared. I'm going to multiply the fraction by y squared. So in the numerator, I'll have y squared plus y. If I multiply 1 by y squared, I'm going to get y squared. If I multiply 1 over y by y squared, I'm just going to have y. In the denominator, I'm going to have y squared minus 1. I'm going to factor the numerator. That'll give me y plus 1. And I'm going to factor the denominator as the difference of squares. Y plus 1 multiplied by y minus 1. We can cancel the common factor of y plus 1, so we're left with y over y minus 1. And that's now a single fraction fully simplified. With this one here, we could use polynomial long division. What I'm going to do instead is factor the numerator as the sum of cubes and the denominator as the difference of squares. So in the numerator, I can write this as x plus 1 multiplied by x squared, then we're going to have minus x plus 1. If we just consider now, x multiplied by x squared will give us the x cubed, then we're going to have minus x squared plus x, then we'll have plus x squared minus x plus 1. So that now is the sum of cubes, and all I've done is taken out a linear factor. Again, you could use the factor theorem to take out now a common factor here. So if you said let the f of x be equal to x cubed plus 1, if you did the f of minus 1, that would give you 0. Therefore, x plus 1 is a factor, and you could take it out. Alternatively, you could use now polynomial long division, or you could go ahead and equate coefficients. I'm now going to factor the denominator as the difference of squares. That will be x plus 1, x minus 1. All we need to do is cancel those off, and we've got now x squared minus x plus 1 over now x minus 1. Okay, let's move on to the next one. Now the next one, I've got a difference of cubes. This is an example of a sum of cubes. The difference of cubes, we can take out x minus 1. That will leave me x squared. Then this time we're going to have plus x and plus 1. So these are standard results. That is going to be over now, and I'm going to factor this as x, then we're going to have x plus 1. We're going to multiply this by the linear factor of x plus 1, and then I've got the linear factor of x minus 1. We can see that the x minus 1s are going to cancel, and the x plus 1s are going to cancel, and that will simply leave us now a quadratic expression of x squared plus x plus 1 divided now by x. So that's a single fraction in its simplest form. So I've seen now that this is the difference of cubes. I saw that that was the sum of cubes. These now are the difference of squares. We factor and simplify. So some extension work on simplifying algebraic fractions. So we look now for the difference of squares or the difference of cubes or even the sum of cubes. We cancel common terms and then write it in its simplest form.